So today we are going to talk about Direct Lake feature in Microsoft Fabric and Power BI. And this session is a combination of my learnings of using Direct Lake in previous, slightly more than a year in production environments. So yeah, let's start, and then I'm also looking forward to hearing your thoughts about Direct Lake, especially from someone of you who probably use this in real life, and yeah, maybe we can exchange some useful advices and experiences. Okay, so first of all, a short introduction, and I own an explanation why Mozart. So my name is Nikola. I'm originally from Belgrade in Serbia, but for the last almost 9 years, I live in wonderful city of Salzburg in Austria.
Mhm.
And Salzburg is a birthplace of Wolfgang Amadeus Mozart. So when I was considering how to start blogging, which nickname to choose, I was like, yes, everything here in Salzburg is in sign of Mozart. So there are no data Mozarts. Why should I not be a data Mozart? That's the
Mhm.
reason. So it doesn't have anything with my passion about classic music or whatsoever. It's just because I'm based in Salzburg, and uh, yeah, that's why Mozart. You can find me on web, data-mozart.com. That's where I'm blogging. I'm also active on social media, LinkedIn, Twitter, or X now. So yeah, feel free to connect if you like. I'm always happy to chat about data-related topics. I'm also currently writing a book called Fundamentals of Microsoft Fabric together with my friend Ben Weissman. We hope to have it ready and published in the first quarter of, I wanted to say next year, but we are already in 2025, so this year. And yeah, other than that, I love spending time when I'm not working with data, I'm spending time with my family. I'm a huge football fan, Barca supporter, and yeah, that's more or less about me. What we have on our agenda today. So first, we are going to revisit and talk a little bit about Power BI storage modes to put our discussion about Direct Lake in the proper context. Then, since I think this is of paramount importance for properly understanding how Direct Lake works, we need to lay some theoretical background and understand what is under the hood of data storage in Microsoft Fabric, and this is Parquet and Delta format. We will cover key concepts in Direct Lake, draw the line between default versus custom semantic Direct Lake models, talk about benefits and some limitations, what you need to think about before you implement Direct Lake models, also analyze some possible use cases and scenarios uh, about when to use Direct Lake, and of course there will be a few demos. I want to show you a few of these concepts, how they work in reality. So when I'm doing this session in a physical room, I like to ask people, do you know what does this function return? And yeah, obviously it's because you all speak English and understand English. This function index return today's date. And why I'm using it here as a reference, because whatever I tell you today during this session is relevant as of today, meaning things are changing rapidly in Fabric world, and Direct Lake as a feature is not the exception. Therefore, always bear in mind, especially if you are watching recording of this session after a few weeks or few months, don't blame me like Nikola told us that this is not possible with Direct Lake. Maybe it will be possible in a few weeks or few months, who knows? And therefore, everything is subject to change. This is a disclaimer because we are talking about Fabric and we are talking about the feature that is part of Fabric. So everything that I tell you in this session is relevant as of today. With that in mind, and there are many ongoing discussions I saw on social media, uh, what's happening now with Power BI now that Fabric became a thing in the last few months, or let's say a year or so. So the question I'm getting more and more from people, I'm a Power BI professional. What should I do now? What should I do now when Power BI became a part of Fabric? And what I'm telling them is relax. So don't stress. everything that you learned about Power BI is still absolutely relevant. Nothing has changed. There are few things, few concepts uh, that were introduced with Fabric and that are affecting Power BI, but all your current knowledge, all your current skills are still absolutely relevant in times of Fabric. So don't panic, just relax. And of course, learn some new things. That's why we are here today, to learn one of these new features that is called Direct Lake. So to go one step back and reiterate what we had as a from the perspective of Power BI architecture before Fabric, uh, just a short recap. I'm sure that most of you know this, but still, just to put again a discussion in the proper context. When we are dealing with Power BI before Fabric, we had two mainstream storage modes. First one is import mode. That's the default storage mode in Power BI, and it's the most desirable way of working with Power BI semantic models. With import mode models, what we are doing, we are essentially taking data that is stored. Let's say this is our relational database, and there are some tables in this relational database. So what we are doing, essentially, we are bringing this data into Power BI's local database, which is called Vertipack. That's the cube in the middle. I know that in reality it probably doesn't look like a cube, but let's think about it as a cube. So that is the instance of analysis services tabular database. And we store this data that we loaded from data source, we store this in Power BI's database. And whenever our users interact with reports, those reports are generating DAX queries, and these DAX queries are then executed directly against data that is stored in Power BI's database. So they don't go directly to a data source. We are querying the data that is stored in Power BI's database. Now, the main benefit of import mode is a super fast performance. It's because of multiple reasons. The most important one is that the data is stored in memory. So in RAM memory, Vertipack is an in-memory database. So whenever you load the data into Power BI's database, it's stored in memory and data is retrieved very quickly, even when we are talking about large amounts of data. But there are two downsides when using import storage mode, or let's say two considerations. First one is data duplication. As I already shown you in this example, we are creating duplicate data from here and moving it here. So it's the same data. Physically, we store the data now in two places, the same piece of data in its original data source and then in Power BI's database. And data latency, because what's happening when we say we want to use import mode, we load the data into Power BI at specific point in time. So we create a snapshot of the data at specific point in time. And then as long as we don't refresh this data, Power BI report will query the data that was loaded last time into this instance of analysis services tabular database. So it may happen that, let's imagine that you have 1,000 rows in these tables on the left-hand side. You created a snapshot at, now it's 7:12 p.m. on my side. So let's say at 7:12 p.m. I loaded these 1,000 records into Power BI's database. There are 300 new records in next 5 minutes. As long as I don't refresh my Power BI model, I will not, or Power BI will not have an idea about these additional 300 rows. So we need to refresh our data. How frequently do we want to refresh our data? It depends on your specific business requirements. It can be every 30 minutes, every 3 hours, once per day, once per week, and so on. That's how import mode works. Now, the second option is called direct query. And direct query is 180 degrees opposite of what import mode is doing. With direct query, we are not moving any data into Power BI's database. Power BI's database still exists, but it just stores the metadata. So information about the data, table names, column names, data types, and so on. But the physical data is stored here on the left-hand side in our tables. And whenever user interacts with the report, these DAX queries that are generated by visuals are translated to a SQL language, and the data is retrieved at the query time. So direct query overcomes those downsides from import mode. There is no data duplication. Again, it's just metadata, and it's real time. Basically, whatever is stored in your source system at the query, at the moment when the query is generated, this data will be retrieved and displayed in Power BI report. So we have real time, or let's say near real time data with direct query. But then the fair question would be, why are we not using direct query as our default option when it solves these problems from import mode? And I would say all of you who ever touched direct query, we can agree that performance is, let's say, way worse than with import mode. That's the main reason why we are not using direct query as our default choice, and that's why, I mean, direct query has its own use cases, but when it comes to performance, import mode wins all the way. Okay, so now we have some understanding of the Power BI architecture before Fabric. And now with Fabric, there is a new option called Direct Lake. In a nutshell, we will examine all of these feature in more detail in next 45 minutes. But in a nutshell, Direct Lake tries to overcome downsides from both import and direct query storage modes. How it works from a 10,000 feet high level perspective. Again, data is not stored in Power BI's database. So same as with direct query, data stays outside of Power BI's database. It's just metadata here in the middle in this cube here. And again, whenever user interacts with the report, DAX query will be translated, this time not to SQL, but to something else. And the data will be retrieved at the query time. But this time with the performance that is equal or almost equal to import mode. How is this possible? We'll examine during next few minutes. But what I wanted to tell you is the way the data is stored in one lake, which is the central storage repository in Microsoft Fabric. The way we store the data in one lake in Delta format is very similar to how the data is stored here. And Power BI doesn't need to spend too much time of translating this data from native storage in Delta format to the format that is the same as with import mode. That's the key ingredient. So let's go now and explain this in more detail. So with Fabric, we have additional options. So import and direct query, I want to stress this multiple times during this session. Import and direct query don't go anywhere. So they're still absolutely valid option for when using Power BI. But with Fabric, you have additional option to consider when you are implementing your Power BI solutions. Some of the prerequisites and how this Direct Lake, what you need to fulfill before you start implementing Direct Lake models. First, you need Fabric capacity, which is marked with F. So F SKU, or for some time in the future before Microsoft deprecates it, Power BI Premium or P SKU. So Premium per user doesn't work. Power BI Pro license, whatever other type of license you have, they don't allow you to create direct lake models. So it's either F or P SKU. So capacity-based licenses. Then you need to have Lakehouse in Microsoft Fabric with SQL endpoint for direct query fallback. Don't worry, we will explain what direct query fallback is, or warehouse. So it doesn't matter if you choose Lakehouse or warehouse, direct lake works with both. Delta format, this is important. So if you store your data in a Lakehouse in any other format which is not Delta, those tables cannot be used for direct lake semantic model. So Delta is a must. And then we have one additional It's not a prerequisite. That's why I put this small asterisk symbol at the end. So it's called V-ordering. Again, I don't want to bother you with too much technical things behind this concept. I would just say that this is a fabric-specific way of additionally optimizing your Parquet files when writing the data into one lake. This one is not a hard prerequisite, meaning if you have a delta table that is not V-ordered, direct lake will still work, but then you can expect performance degradation. At least that's what Microsoft says. So they guarantee if your tables are V-ordered, your delta tables are V-ordered, that you will get the maximum possible performance from direct lake, whatever that is. Okay, so let's dive into a lake full of Parquet and delta files. And I think this part is important to understand, not only from a direct lake perspective, from understanding direct lake perspective, but also generally when we talk about fabric, because everything in one lake is basically in the end stored as delta format. Before we explain why is this important and why Microsoft took this bet to go with open source format, which is delta, let's take one step back, or maybe two steps back, and explain how Parquet stores the data and why it is nowadays considered a standard for storing data in analytical scenarios. A long time ago, we relied on traditional relational database management systems, which was storing data as a sequence of rows. So it's so-called row-based storage. And in this example here, this is of course a very simple example where we have data about products, customer, countries, so usual fact table. With row-based storage, when you want to answer a question, a common business question such as how many t-shirts did we sell in USA, the engine has to do something like this. So it needs to scan all the rows. Don't forget, data is stored as a sequence of rows. So all the rows and all the columns. And for analytical scenarios, so we are talking about analytical scenarios, this is not the most efficient way of retrieving the data. I think we can agree on that. And then maybe 20 years ago, or maybe no, less than that, maybe like 15 years ago, column-based storage was replaced by column-based storage. In column-based storage, this same data is stored in a very different way. Not from a perspective of looking at this slide, it looks the same, but from the storage perspective, now each column represents a separate physical unit. So data is stored within each column as a separate physical unit. And then the engine can skip scanning unnecessary columns. Going back again to our previous example, how many t-shirts did we sell in USA? The engine can skip scanning customer data and sales amount. Just scan two columns. That's column-based storage. But column-based storage existed before Parquet, still exists outside of Parquet. So what's the deal with Parquet? Parquet stores the data. So Parquet is a columnar storage that stores the data in row groups. So we have additional structure introduced with Parquet, not just vertical separation of data, but also horizontal separation. And this is how the same portion of data will look from Parquet storage perspective. Now, why is this important? When we talk about analytical scenarios, we are mainly concerned with two concepts: projection and predicate or predicates. Projection refers to select statement in SQL. So which columns our query need? In this case, we need two columns. We need product and we need country. So the engine can skip scanning those remaining columns that are not required by our query. And predicate refers to where clause in SQL language. Which rows satisfy criteria defined in the query? Don't forget, we are interested only in t-shirts. So in this case, the engine can skip scanning these records. It can completely skip scanning row group 2. Now, if we go back and analyze the difference between these three approaches, with row-based storage, we have the engine to answer the question, how many t-shirts did we sell in USA? The engine will scan 5 columns and 6 rows. With column-based storage, 2 columns, 6 rows, it's better. With Parquet, it's 2 columns and 4 rows. Now, obviously, this is oversimplified example. With 5 rows and 6 columns, you will not see any difference in performance, whatever you choose. But when we talk about analytical scenarios, it's usually millions, sometimes billions of rows. So this difference can be really significant. Now the question is, can it be better than this that I explained? Yes, it can with delta format. Now, what is delta format? Don't be confused. Parquet is just a physical way of storing the data. Delta adds this, let's say, brain on top of this physical storage. And I consider delta as Parquet format on steroids. And when I say steroids, this brain stuff, this sophisticated stuff that delta introduces is versioning of Parquet files, storing transaction log, and tracking all the changes that you make to your data, because by its nature, Parquet is immutable. So once you update the data in Parquet file, it doesn't change the existing file. It creates a new version of the file. That's why delta is important, because it lets you track all the changes that were made to data that was stored in Parquet files. And this is how delta format will look like when you open it from OneLake Explorer. So we are talking now about Fabric. You see that I have multiple Parquet files that are storing the data for my CMS underscore provider drug costs table. I have multiple Parquet files, and I have this delta log folder on top of it. When I open this delta log folder, those are different versions of the files that were in the background for this specific table. So delta keeps the track of changes that are happening. With described history, you can go back and see when each change was made. Now, going back from this story about Parquet and delta to Microsoft Fabric, I already mentioned that you can use direct lake storage mode with both lakehouse and warehouse. There is a slight difference in user experience when you create a lakehouse versus warehouse. When you create a lakehouse in Microsoft Fabric, you get 2 additional Fabric items out of the box provisioned. Even if you don't create them, even if you didn't create them explicitly, Fabric will create them automatically for you. It's a default Power BI semantic model, which is in direct lake storage mode already, and you can't change this. You can't change this to import or direct query. And you get a SQL Analytics endpoint that exposes all delta tables from your lakehouse. They are exposed through the SQL Analytics endpoint. And then on top of this, we can build our own so-called custom semantic models. The official name is not custom semantic model. The official name is semantic model. But just to be able to distinguish between these 2 default and semantic models, I will call them custom semantic models. So those are the models that we build on top of our lakehouse data. With warehouse is similar. The only difference is that we don't get SQL Analytics endpoint provided as a separate item, because SQL Analytics endpoint is already built in the warehouse. So we just get default Power BI semantic model, and again, we can create our own semantic models on top of it. So just to show you quickly this distinction between default semantic model and custom semantic model, I'm currently in Fabric workspace called TP600 Playground, and as you can see, I have a lakehouse called, maybe I can scroll it like this. I have a lakehouse called CMS underscore LH. When I'm talking about this CMS dataset, maybe it's a good moment just to give you a quick heads up. It's an open dataset that you can download from GitHub, containing data about some healthcare industry. I don't know, around 220 million records, which is good for playing around with Fabric. And yeah, so this is my lakehouse. This is my default semantic model, and this is SQL Analytics endpoint. So default semantic model, if you click on it, you can't open it from web user interface, at least not directly from semantic model. There are some tricks how you can do this. If you go to SQL Analytics endpoint and then under reporting, here you can manage default semantic model, and then you can see which tables and which views are included in default semantic model. What I'm suggesting, and what is a suggestion from Microsoft as well, is to limit the usage of default semantic model. So it's a good starting point for, I don't know, some ad hoc data exploration and so on, but in real production environment, you don't want to rely on default semantic models because they have many limitations compared to regular custom semantic models that we build on our own. And as you can see here, I have one semantic model called CMS_DL. That's the model that I built. This is custom semantic model that they built on top of this lakehouse. How it's done? You can do it in multiple different ways. If you open a lakehouse, there is the option new semantic model. Once you click on this option new semantic model, define the model name, choose the workspace where you want to store the model, and then finally choose tables and views that you want included here in this model. So you see immediately that you have way more flexibility, so you don't need to choose all the tables. You don't get built-in system views included in your semantic model, which is the case with the default semantic model. So that's why I encourage people, use custom semantic models. Don't be lazy, create custom semantic models and use them. With custom semantic models, you can access them also from web UI. Let me just quickly show you. So if I go here now, open data model option is enabled. So I can open my data model, and from here, everything looks familiar. Everything works the same as with import and direct query modes if you edit those models directly in web UI. You can also use Power BI Desktop. Since recently, you can also use Power BI Desktop to manage your direct lake semantic models. Yeah, so use custom semantic models. That's essentially my main message about default versus custom semantic models. Once again, how this, is it magic or not, bro? It's not a magic, but it's an architecture built by Microsoft here. How this thing work? How does this thing work in the background? As I already mentioned, Parquet is very similar to how Power BI stores the data in import mode. So Vertipack database, the way the data is stored, algorithms for sorting your data and everything else is very similar how the data is stored in Parquet. And therefore, Power BI engine can read delta tables directly from one lake. And semantic model, once you create semantic model in direct lake, is initially empty. It just contains metadata. And then it loads the data in memory on demand. Now, this can be a little bit hard to grasp. So I want to spend some time to explain what does this mean, loading data into memory on demand. Here is our use case. This is our happy Power BI user. And they have their favorite report, which is connecting to a semantic model. This semantic model is in direct lake storage mode. So what's happening in the background? We have our fabric architecture. We have a lake house with SQL endpoint or warehouse, whatever you prefer. And we have some tables inside. So we have some delta tables exposed through the SQL Analytics endpoint or through the warehouse. And then we have one lake, again, central storage repository for the entire organization that leverages Microsoft Fabric. And within one lake, we have multiple different delta tables. So those tables are exposed. So these tables here are exposed through the lakehouse SQL endpoint or warehouse. Now, when user interacts with the report, only columns that are needed by the query will be loaded into semantic model. And from that moment, once the columns are loaded from delta tables into semantic model, this guy here behaves the same way as import mode. This is important. Once the columns needed by the query are loaded into semantic model, they behave the same as with import mode. So they are in memory, and Power BI will serve the data from in-memory storage. That's why we have performance which is equal to or very close to import mode, depending on different things, but very close. The logic, the technically, it's the same thing. Now what happens, or let's explain what does this mean columns needed by the query. Let's say we have two tables. We have a customer table and we have a sales table. So one dimension table, one fact table. And let's say that we have a visual in our report that displays total sales amount by first name. I know it doesn't make sense, but this is just for the sake of explaining how this works. So first name and total sales amount. So what happens is that only those two columns will be loaded into semantic model, into memory. So the engine will just load these two, first name and amount. I lied a little bit, but I have a good reason to do that. It's not just those two columns, it's also columns that are part of the relationship because of the filtering and all the other stuff. So Power BI will load those columns that are part of the visual and will also load into memory relationship columns because, as I said, for this obvious reason, so that your filters and everything else propagate faster. So essentially in this case, instead of having 1, 2, 3, 5, 10 columns in memory, we will have only 4. That's how direct lake works. That's also how import works when you enable large storage mode format. So it's very, very similar, or let's say from pure technical perspective, it's the same. Now, few things to keep in mind. When semantic model loads the data from one lake into memory, the entire column goes into memory. So it doesn't matter if you partition your delta table per year, per month, whatever. And for example, let's say you partition per year and your query is just retrieving data for 2024. The entire column will be loaded into memory. So partitioning doesn't happen on a semantic model level. The entire column goes into memory. What if direct lake doesn't work for whatever reason? We will explore what are the reasons, possible reasons for direct lake not to work. If direct lake doesn't work, in most cases and by default, your queries will fall back to direct query. We'll examine later how you can control this behavior, but by default, then your query will go directly to these delta tables and query them using SQL language. So all the benefits and all the benefits of regular direct query apply in this case, and performance will be probably much different compared to when direct lake mode is possible. So if direct lake doesn't work, by default, direct query will take place. Now, a few concepts to keep in mind when working with direct lake. First is what happens when I add new tables to my lake house. Does this change automatically reflect to semantic model that is built on top of this lake house? As usual, it depends. So by default, it's set to off, meaning if your semantic model contains 5 tables and there are 5 new tables arriving in your one lake, as long as you don't add those tables to your direct lake semantic model, they will not be part of it. So by default, this option is turned off. You can turn it on if you want. So you need to handle this synchronization between one lake and semantic model in terms of new tables. This is when the new table is created. Now, what happens when new data is coming into the table that is already part of the semantic model? Going back to the previous example, I had a table with 1,000 rows. There are 300 new rows. What happens? Now we are talking about refreshing semantic model in direct lake storage mode. And this is a very different operation compared to refreshing import mode semantic model. Don't forget, semantic model in direct lake mode stores only metadata. So when you use import mode, you have physical data stored in the model. And when you hit the refresh button, doesn't matter if it's manual or scheduled refresh, when you hit the refresh button, Power BI will go and physically pull this data from the data source and place it and store it in semantic model. So if I have 500 million rows in my data source, Power BI will go and pull these 500 million rows and load into semantic model. And I have a semantic model with 500 million rows. With Direct Lake, when we do a refresh, and let's say again, we have a table with 500 million rows. Those 500 million rows, they stay in one lake in Delta table. They're not part of semantic model. Semantic model just stores the information about column names, data types, and so on. So just metadata. And refreshing Direct Lake semantic model, as you will see in a demo, is usually a very cheap operation in terms of resources, time, and so on. So even if you have a table of, I don't know, 500 million rows, 1 billion rows, refreshing Direct Lake semantic model will not take more than 30 seconds. Try to do that with import mode. I think this is the biggest difference in terms of feature-wise comparing refreshing import mode models versus Direct Lake models. Now, there is an option to refresh semantic model, Direct Lake semantic models. Unlike in previous example where the synchronization is turned off, in this case it's turned on. This means that Power BI will every minute or so check if there is a new version of Parquet file in one lake. If yes, it will load this data into semantic model. If no, nothing happens. Again, you can decide if you want to keep this default option turned on, or if you want to turn it off. It's up to you. Now, a little more about this process of Direct Lake refresh, which is also known as framing. So how this thing works with Direct Lake. With import, it's obvious, so we don't need to do the analysis of that. I'll just focus on Direct Lake here. So we have a semantic model in Direct Lake mode, and we have some Parquet files that are currently part of semantic model. Let's think of this as a frame, okay? Because that's why it's called framing. Now, what happens when new version of the file arrives? First, everything that was already in memory will be kicked out, and then this frame will become bigger, will expand to include the latest version of the file. So we have the latest version of the data available in semantic model. That's how refresh process works in with semantic models. I'll give you a very simple example. I have dim customer table that contains 2 Parquet files and Delta log folder. What happens if I update the information about the specific customer? So the new version of the file will be created. That's the one. And then when I refresh the data, oh, sorry, here is the new version, 002. So when I want to include this latest version of the data into my semantic model, I need to refresh or reframe data that is stored in semantic model. Again, don't forget framing or refresh process in Direct Lake means only refreshing metadata, not the physical data. So these are the 4 key concepts, in my opinion, relevant for Direct Lake. Synchronization or syncing, meaning how do you handle new tables that arrive to one lake? How do you handle this scenario and how you synchronize that with your Direct Lake semantic model? Then we have framing that we previously examined, adding the information about the latest version of the file or latest version of the data to your Direct Lake semantic model. Transcoding, or this is the process of loading the data on demand in memory. I already mentioned whenever query needs a certain column, this column will be pulled out from Delta table in one lake and loaded into a memory. So this process of pulling the data out of one lake, making some changes on the fly on this data to store it in the form that Power BI can read it the same as it was stored in Vertipack with import mode, it's called transcoding. And finally, we have a concept of temperature that I will show you in a demo. That is the concept where Power BI keeps those frequently used columns in cache memory. we'll see in demo, everything will be much easier to understand. So let me show you few of these things in demo. No, this one. Okay, so let's go and let me show you what I have here. So I have two semantic models. One is, they are based on the same data. So absolutely the same data. It's this healthcare publicly available data that has 220 million rows, something like that. So I created two models, import mode model and direct lake model. All the tables are the same, data types, everything is the same. And if I connect with DAX Studio to my direct lake model, and let's find this one. So what happened here? 2 hours ago, I was playing around with this model, and I assume that something is still in memory. Let's see the size of this model in memory. So I'm using Vertipack Analyzer, built-in tool within DAX Studio to analyze the details about my semantic model size. Let's wait for a few moments.
I've got a question if you want, Nikola.
Yes, sure.
So Omar said, does direct lake mode work via a Databricks lakehouse via an Azure blob storage, since Databricks saves data as Delta and Azure blob storage is very similar to OneLake?
Yeah, so as long as it's Delta, it works. Okay. So Databricks doesn't do V-order, the thing we examined. It has some different optimization algorithms, but as long as it's Delta natively, it works with Direct Lake.
Great, brilliant.
Okay, so what I wanted to show you here is this concept of temperature, and the columns with the highest temperature are the ones that have the biggest chance to stay in memory. Now, because this is my personal machine and there are not many parallel or concurrent workloads here, probably these columns will stay for a longer time in memory. But in a real life, when you're in the organization with many concurrent users, concurrent workloads, many interactive operations, loading data for different semantic models and so on, what will happen? The engine will decide which columns are most commonly used, and then it will keep those columns in memory. Because when columns are in memory, they can be served faster than if the engine needs to go and pull them out from OneLake. So in this case, you see that those key columns that are part of the relationships have highest temperature. Now what happens if I go here and let's build report on top of our direct lake semantic model? So I'll do something very simple. Let's use year, and let's use row count, and for example, total claims. You see the performance. So because most of the data is already in memory, you see that 220 million rows, it's almost instant. So there is no lag, nothing. The first load may take a little bit longer. This process of transcoding, this process of going to OneLake, moving the data, translating it on the fly and loading into memory may take a while, but also there are some solutions to this. But when the column is in memory, that's the same from pure technical point of view, it's the same as import mode. From now on, when the columns are in memory, it's the same as import mode. So I used some columns here. Let's pretend I'm the user that uses this report. And if I go back and run this query again, now you see that those columns that I'm using in my visual, they moved on the top. So year column, total claims, total supply, whatever, they are now above my relationship columns. And those columns that are not used, some of them are outside of memory, and some of them have a very low temperature value. If I use this mean year, for example, that has value, a temperature value of 3. Let's just show how this concept works. So let me find where it is. I'm not sure. Do I have it? Where it is? Which table? So it's the geography. Okay. Okay. Maybe it's hidden. That's the reason. That's the reason. Oh, I'm not seeing it. And I can't. Yeah, I need to change this on a model level. So let's open quickly this model. And where is my table? Geography, and then mean year and max year. So now if I go here and refresh it, now I have my max year and I have my mean year. Whatever this represents doesn't matter. From the pure concept of temperature, let's check what happens with mean year and max year columns that had value of temperature 3 something. So now when I run this, oh, it's even lower. No, this is different table, sorry. So it's now 7. In case I start using this more and more, the temperature will rise. Also, for other columns that are not used, it slowly cools down. So for example, if I don't touch this report in the next half an hour or 1 hour, you will see that temperatures will not be 31 or something, will be probably 15, 14. So the temperature of the columns cool down after some time of being idle. So that's the concept of temperature. The engine keeps all frequently used columns in memory so they can be served as fast as possible. Now going back to a presentation. I mentioned falling back to direct query, and let's examine what does this mean. Direct Lake has some built-in guardrails depending on the capacity that you are using. You can see the table that I pulled from Microsoft Learn official documentation, and different guardrails that will be applied to a particular capacity. So for example, if you have F2 capacity and you have a table with 500 million rows, you can't use direct lake because the maximum value is 300 million rows within a table. Also, different constraints related to maximum model size on disk. This one is interesting, maximum memory in gigabytes. This is per query, not per model. So this one refers to a query. The bigger the capacity, the less restrictive these guardrails are for direct lake. Of course, you pay more, you get more. Those are guardrails. So whenever you hit any of these guardrails, there is no direct lake. Plus some additional things that we are going to consider. You can always check, there is a dynamic management view that you can execute from DEX Studio or SQL Server Management Studio to check the fallback reason for direct lake. If it's 0, then it means direct lake is happening. That's good. Now there is a special property called direct lake behavior. I already mentioned in one of the previous slides, by default it's set to automatic. Automatic means direct query will happen if direct lake is not possible. So it doesn't matter what the reason is for direct lake not being feasible, the query will fall back to direct query. That's automatic. But you can change this behavior. You can set it to direct lake only, meaning whenever you hit any limitation for using direct lake, the query will throw an error. And the third option is direct query only, meaning there is no direct lake at all. Your queries will be executed using direct query mode. Some final thoughts. We already examined what happens if you are a Power BI professional. What if you're a Power Query guru? What should you do now? I don't have so great news for you like previously. There is no Power Query in direct lake models. So you can't open Power Query editor and perform your magic. No Power Query in direct lake models. But still I have a good news, and that's you can use data flows gen 2. So go one step upstream, prove your Power Query skills in the Power Query Online editor for Data Flows Gen 2. Perform all your transformations before you load the data into one lake. So you still can leverage your Power Query skills, but in a different place and one step up in this entire process of bringing data into semantic models. What about row level security? I also get a lot of people are approaching me and asking, they heard that there is no row level security in Direct Lake, or that if you implement row level security, Direct Lake will not work. So to clarify this, there is row level security as we used to know with import and direct query models. When you define row level security on the semantic model, Direct Lake will still work. In theory, of course, if you don't break any other rule, but with row level security alone, Direct Lake works. But if you enforce row level security on a table that is queried through the SQL endpoint, meaning if you enforce row level security directly on the table that is storing the data in one lake, then all your queries for Direct Lake semantic models will fall back to direct query. That's the only difference. So if you do the regular thingy with setting row level security on a semantic model, you're good to go. Limitations of Direct Lake. Again, as of today, things are changing. Don't forget this. You can query just a single lakehouse or warehouse. Meaning if you have some tables in lakehouse A and some tables in lakehouse B, you want them into Direct Lake semantic model, it's not possible. But there is a workaround. There is a feature called shortcuts in Microsoft Fabric. What you can do, you can create shortcut in lakehouse A that points to a table in lakehouse B, and then you can use this table in your Direct Lake semantic model the same way as it was natively stored in lakehouse A. So shortcuts can help you to overcome this limitation. No DAX calculated columns and calculated tables. Don't know if this is good or not, but it's not possible because, as you know, they are recalculated, they are persisted at refresh time. And again, don't forget, there is no refresh in Direct Lake, just a metadata. So we don't have any data to recalculate and persist in semantic model. No composite models. So it's Direct Lake and that's it. So you can't put 3 tables in Direct Lake, 2 tables in import mode, 1 in direct query. That's not going to work. So it's just Direct Lake or something else. No relationships on date time data type columns. So just this limitation applies only to relationships. You can have date time columns in your semantic models, but if you want to create a relationship on those columns, this is not supported, at least not yet. No partitioning. You know that using tabular editor or some other external tools, we can partition tables that are part of semantic model, for example, in import storage mode. So we create partitions on a semantic model level. This is not possible with Direct Lake. It's always a single partition. You can't change that. But again, as with Data Flows Gen 2, going one step back, you can apply partitioning on a delta table level. Here is the link. So I will send the presentation to you. Here is the link of all the current limitations from Microsoft's official documentation. And make sure to always check the list before you start working on Direct Lake models. Maybe some of these that are listed here will not be limitations in the future.
Brilliant. Sorry, carry on.
Sorry. Yep. Some of the benefits, performance really comparable to import mode. They allow, using this allow you to eliminate the serving layer. Previously, we had to use additional components in our architecture, like Azure Synapse or Azure SQL DB, if you're talking about Microsoft solutions. Now with this, we can avoid this part. Refreshes in import mode may, depending on how big your data is and how big your semantic models are, can really be an exhaustive operation for your capacity. So with Direct Lake, we don't have this issue. Shortcuts, I already mentioned them in the previous slide when talking about bringing data from multiple places into one lakehouse. And of course, going one step beyond this, you can use one single copy of data stored in one lake, not just for direct lake, but also for other workloads. To wrap up, direct lake is a fantastic feature. There is no single doubt about it. So it is an amazing feature, but it's not a solution to rule them all. There is no such a solution. Unfortunately or fortunately for us consultants, I don't know, but it's not the one solution to rule them all. Okay? If you are happy with your existing import models, don't switch them to direct lake, at least not yet. Still, there are many more limitations on direct lake compared to import mode. So if you are happy how your import models work, don't touch them. Don't change anything. When I'm being asked when to use direct lake as a default choice, so before import mode model, I would say for companies that are just building their lake-centric architecture, so they are starting like a greenfield project, I would say maybe in those cases, direct lake can bring them more benefits than using import mode. Again, depends on many different things, but that's one of the most obvious scenarios where I see direct lake can win over import mode as a default choice. And again, since the entire fabric is new, including direct lake, we are all still learning when to use direct lake. That's all from my side. I'm almost on time. Sorry for going maybe a few minutes above. Happy to hear any questions if there are any.
Oh, that was brilliant. Thank you so much. I didn't interrupt because you were on full explaining mode, and I think because it's such a complex topic and there's a lot to get through, it would have, it can distract you, and then, because the flow of the presentation was brilliant in going from the start to the finish. Most of the questions we've talked about in the chat as you were going. So Anthony and Donald have kindly put in a couple of links to the considerations and limitations. And I'll thank you for offering to share the presentation. I'll put a copy in we've got a GitHub site, so I'll put a copy in the GitHub site. There was a question from James which said, does a lakehouse endpoint semantic model and a warehouse semantic model now work 100% the same when used in Power BI? They were early adopters of Fabric and found that some of the models needed relationships rebuilding and some other issues from the warehouse.
Yeah, officially they should work 100% the same because it's the same engine in the background. So it's the engine that uses warehouse is engine from Synapse, Polaris. The same engine works when whatever you do with SQL Analytics endpoint of the lakehouse, it goes directly to the same engine. So it should work the same. I can't confirm myself 100% because my experience was 100% related to lake houses and working with direct lake mode with lake houses, but should be the same.
Yeah. I must admit, most of mine's been with lake houses.
And great point from Anthony. SQL views don't work with direct lake. Or to be 100% correct, you can use views as part of your direct lake semantic models, but then the queries will fall back to direct query. So it's not that you will get an error. You can include them, but then it breaks direct lake.
Yeah.
But that's the thing, though.
That's a good point. That's a good point. Yeah, thanks, Anthony.
And that's the thing, though, is that it can get very confusing when you say, oh, direct lake. But then you go, well, hang on, but that's a caveat, which is like, well, but it doesn't work with direct lake. So why can you say that it works with direct lake? Yeah, things will work, but it actually doesn't work.
So as long as the query doesn't need data from the view, it will be direct lake. But as soon as it needs data from view, then it breaks direct lake. Yeah. So I had a discussion with product group a few months ago because documentation was very confusing on that topic. So I was also, my understanding was also that you can't use views, but technically you can, as long as the query don't need data from the view. But
which is
I suggest avoid them if possible, because you never know when the query will retrieve data from you, and you probably want to avoid this behavior of not having direct lake when you build direct lake model. Yeah, that's
It
a good
seems
point, Sally.
like, yeah, I think as Chris Webb mentioned something about, and one of the questions was about DAX restrictions when using direct lake. And I think it is that sort of, it's almost like when you use Power Query, you want to think about what you're asking it to do when you create things, to sort of
So
get an understanding of how it works, so that you can then, try to understand the way that it's working as to whether it will go to direct query or whether it will be direct
so
lake.
as long as the queries are served using direct lake mode,
Yeah.
everything that you can use in regards to DAX, everything that you can use with import mode works with direct lake, because data is loaded in Power BI's engine. From that moment, everything is the same as with import mode. But if you break direct lake, then all the limitations of direct query apply. That means if you have a DAX statement that might possibly work with import mode, it will work as long as you have direct lake. But when direct lake is not possible, if it falls back to direct query and it's not supported for direct query, then it will not work.
Yeah.
So
Yeah.
kind of, yeah.
Yeah. But it's new, like, yeah. It's getting your head around what you can do. And like you said, I think the summary at the end is not the solution to everything, but it can be a solution to some things.
Yes. Again, I would say still
storage
a
is
lot
key.
of limitations to make a decision to switch from import to direct query. That's something I would evaluate multiple times. But if you're just starting, if you have a lake house, so let's say you started, you implemented Fabric or you implemented Databricks, you have a lake house, you have your Delta tables, then it makes sense, especially if you have larger amounts of data, you have these real-time requirements, it makes sense to start with direct lake.
Yeah.
That's my opinion. I'm not saying I'm correct, that's how I see it.
Yeah.
So
Yeah.
yeah. But if you have, like, I don't know, well-performing, well-built, optimized import models,
Yeah.
why
It
would
doesn't
you
need
change this?
instant refreshing. Yeah.
I think that was the point that I'd thought about the other day, was because of that clear out of the cache when you're doing the refresh. Even though it's just the metadata, it depends on sort of really how often are you adding new data to those tables that actually need to go into that report. Because obviously then I think you would lose, you potentially would lose that benefit of having that direct lake if your cache is being cleared out all the time, on a very frequent basis.
Yes. What I realized in the last few weeks, I'm not sure if something changed how direct lake works. So previously, when I did last time this presentation, I don't know, 2-3 months ago, whenever I refresh my direct lake semantic model, everything was kicked out from the cache. Now this is not happening anymore. So now today I refreshed my direct lake semantic model multiple times, but the columns that I've been used in my report before that, they were still part of cache memory. So I'm not sure if something changed in the way they handle this. Is this mechanism became smarter or whatever? But as you mentioned previously, that was the case. So if you refresh your direct lake semantic model 10 times a day, 10 times a day, you need to load the data into it for the first run. That's not happening anymore. At least that's what I experienced, what I'm experiencing now.
That's weird, because they obviously haven't updated the documentation, because 3 weeks ago in the documentation, they were still saying it clears out the cache.
They changed probably because I was looking at documentation today to check this, because I was also baffled with this, with what is happening, and it say columns may be evicted. So they're not saying columns will be evicted. Columns may be evicted. So now it's maybe or may not be, but yeah, you can test it. Today I tried it like 10 times. I refreshed my semantic model. and 10 times columns stayed in memory.
As you
Okay.
say, as of today, 3 weeks
As of
ago,
As of
today,
it
today,
yes,
was.
yeah.
yes, yes.
Anyway, a huge
Oh,
thank you, Nicola. That was such a source of information. It was, you make very complex topics really straightforward and easy to understand. There's been dialogue throughout the chat where we've been talking about different things and discussing things with each other. You've answered all of the questions either with the chat or with the presentation. So it just remains for me to say a huge thank you for me and everyone that's here, and Anthony, for coming and giving this session to us.
Thank you for
And
hosting me. I really appreciate that. Thank you.
oh no, thank you. We've had a masterclass on Direct Lake, so that's
Thank you.
absolutely brilliant. And next week we have the wonderful Andy Cutler, who, I mean, his presentation style is just lovely. I say to him, it's like you're in the pub, with a pint, having a chat is the way he presents, and he's just so incredibly um, informed, like yourself. So to be able to share the technical knowledge with us is very appreciated from all of us.
Andy is
Lots and
amazing.
lots
Andy is
of
amazing. Yeah,
He is amazing. He is
absolutely.
amazing.
Yeah.
Yeah, and so are you. And so we've
Thank
had
you.
lots and lots of appreciation and gratitude and everything in the chat. So a big thank you. I'm going to stop recording now.
Thanks everyone for joining. I forgot to mention this.
Stop.